Okay, well, good afternoon, everyone. Good afternoon. I'm Tim Anderson. Welcome to our webinar this afternoon. Um, I'm the product and business development manager for radio transmission. And today we're going to talk about Flexiva FLX. That's our liquid cooled high power FM transmitter. And a little bit of background, why we developed it, how we developed it, and what's inside. And it's all about enhancing total cost of ownership. So the main push for developing the liquid cooled transmitter, uh, it was really threefold. Uh, there's always striving for higher efficiency, um, higher power density, and of course, these days, there's a lot of movement around the green initiative. One of the first and most serious requests we had for this evolved out of some conversations that Jeff Mendenhall and I had over, I guess, the past 5 or 6 years with our broadcast customers about ways that we could enhance efficiency, power density, and satisfy the green initiatives with liquid cooled transmitters for FM. Now, it wasn't very well received 5 or 6 years ago from the radio broadcast crowd, but the more we talked to engineering management that were involved in both radio and television, it seemed to sound like a better and better idea. And the more we talked about it, the more acceptance we began to see amongst radio broadcasters until it finally kind of got to a point where it was almost in demand. One of the first most serious requests that we heard for liquid cooling of FM radio transmitters was from the new Freedom Tower project, the World Trade Center project in New York City. What they had really planned to do there was do a group multiple transmitter facility all on a building liquid cooling system that was very high efficiency and would satisfy all, both the television and radio transmitters, all in the same cooling system. So we really began to get very serious about developing the liquid cooled radio transmitters. Of course, we'd been doing liquid cooled television transmitters for years, so it really was a very natural evolution. Some of the things that drive these decisions, especially around the liquid cooling, were the issues that our customers are facing. And we all know that the world electricity prices have been increasing, been an average of 6.5% per year over the last 5 years, and it's expected to continue. Energy prices are going up, and it's a big part of our customers' requirements for power. So we began to look at it in terms of power usage. Also, there is a lot of pressure to reduce operating expenses. Now, when we talk about OPEX, we're talking about people, the plant, spares, energy. And some of our customers had told us that the operating costs for the transmitter exceeded 5 times the cost of the transmitter itself. Purchase price of the transmitter is only about 20% of what it costs to deliver their services. Deploying people to the sites can be costly, air conditioning, maintenance, parts obsolescence, those kinds of things certainly add to that OPEX cost. Often the technology that's in play in these facilities is older technology, it's less efficient, and requires more maintenance. So let's talk a little bit about what total cost of ownership really is. And you have to look at it over the lifetime of the transmitter. Total cost of ownership it's thrown around a lot, but generally it means the total cost of an asset through its complete life cycle. In the case of transmitters, for example, where the life cycle, say 10 years, we tend to focus mostly on the operational and maintenance costs because that's quite frankly, where you can get the most return on that investment. So we tend to look at it in different phases: the planning phase, the acquisition phase, operations and maintenance costs, and in that operations and maintenance, excuse me a second, we tend to have to do things like upgrades, maintenance on the cooling systems, general maintenance on the transmitter. That's the actual operational phase, and that's where a bulk of your expenses are. However, they're fairly steady. And then finally, as the transmission equipment comes to its end of life, we look at disposal costs, etc. When you purchase or replace a transmitter, total cost of ownership is more important than just the purchase price. We have to look at things like the acquisition costs, the financing, building space requirements, leases for space, shipping, installation, commissioning, training. And then there's the operational costs, the AC power costs, routine maintenance, repair costs, upgrades, warranties, and those kinds of issues over the operational life of the system. So it's the TCO, or total cost of ownership, that's really important to our customers. It's the total cost to own and operate the transmitter over the life of that system. That includes all of the things that we just talked about. But one of the most important things that we can affect as manufacturers is the efficiency. And the efficiency of the system isn't just the AC to RF consumption of that transmitter. It's other things like the transformer losses and voltage regulator losses, heat loads in the room, and the air conditioning costs, including oh, sorry guys, we hit the mute button by accident. I was coughing. What I was saying is the total cost of ownership is really all of these things combined, but efficiency is the one thing that we can affect most. Things like the AC losses in the transformers and regulators, heat load, and cooling costs, maintenance, replacement of air conditioning systems. The RF system losses, and those can be quite significant, are things like transmission lines, filters, diplexers, where a lot of RF energy is converted to heat and really lost energy. So when we talk about the efficiency of the transmitter, the real definition of that, of course, is RF output divided by the AC power input times 100 gives us an efficiency percentage. Increased efficiency, of course, reduces power consumed and reduces wasted energy. So at GatesAir, we have been working constantly and diligently on updating designs to improve efficiency and total cost of ownership. We've developed with our partners higher efficiency RF devices and PA module designs. Higher efficiency power supplies also play a big role in this, as you'll see. Optimized energy efficient cooling systems, certainly an area that makes a big impact. Broadband future-proof designs, improved uptime, and reduced maintenance costs. Modular designs with faster mean time to repair, higher density systems for reducing floor space, and user-friendly designs that are easier to understand and operate. These are all important factors that we consider in our development to improve the total cost of ownership. Power Smart's been an initiative that we've had here at GatesAir for a number of years now. This is the ongoing initiative to create the most efficient transmitters and products that leverage our most sophisticated tools for cost, energy, and space-saving solutions. We do this for both television and radio in our Flexiva line of UHF transmitters. Began using the 50-volt LD MOS devices and really set the standard for high-efficiency transmitters for television. We, about 5 years ago, leveraged this into radio in the Flexiva family of FM transmitters, and it's giving us outstanding efficiencies up around 72% for FM using these new 50-volt LD MOS devices. Talk a little bit about the power supply technology. The power supply technology has improved by leaps and bounds over the last few years. Improvements in power density to weight have given us very, very high efficiency power supplies where we're seeing 96% or better energy conversion from AC to DC versus 84% only just 5 or 6 years ago. These new power supplies operate from 48 volts to 50 volts, and they leverage the telecom industry's power supplies. These are very standard power supplies in the telecommunications business. So they're high production, high demand devices, readily available with very, very, very high mean time between failure ratings. The particular power supply that we use is made by General Electric. It's a 900,000 hour mean time between failure power supply. So very rugged, very reliable, available worldwide, and available through many vendors. And they're used in all of our products, which make them very versatile both for us and for our customers who may have multiple transmitter platforms and only really need to stock one set of power supply spares. Now, this is an interesting analysis of what happened with the power supply improvements over the years. Here we're taking a look at power consumption of two 10 kilowatt transmitters, both FM analog transmitters. Both are using the same high efficiency LD MOS power devices, same control systems, same cooling systems. The only difference between these two transmitters is the older generation of power supplies versus the newer generation of power supplies. Older generation of power supplies typically around 84% efficiency, while the new generation of power supplies, again, around 96% efficiency. Well, when you factor all the other components in the transmission system in, you can see that there's quite a significant improvement in the overall efficiency of the system. Using these new generation high efficiency smart power supplies, just those power supplies alone, we can see an overall transmitter system efficiency gain of around 13% with 20% lower power supply losses, and that 20% lower power supply loss makes more total power available for the power amplifiers for getting the job done. So this was a huge improvement just moving to this new generation of power supplies. We also should mention RF device technology, also grown by leaps and bounds. And those of you who've heard me speak on this, I've been talking about, LD MOSFETs for a very long time now. We've reached several more generations since we began using them. The new 50-volt LD MOS devices dramatically increase power density, efficiency, and reliability. This latest generation of devices that we're using now, 1,400 watts of peak power per device. And these are still dual Gemini devices capable of 1,400 watts of peak power in push-pull operation. They're high gain, nowadays up to 22 dB of gain. They're high in DC to RF efficiency, upwards and better, 82% DC to RF. Improved thermal transfer characteristics. These devices are much easier to cool now. We can get the high temperatures away from the junctions much faster and cleaner, which lets us run more peak power again and cool them more efficiently. They're also improving all the time on the ruggedness. These devices typically can handle they're tested at 65-1 VSWR at all phase angles. Some of you have probably seen the demonstration videos of these devices being run into a dead short at full rated power, and then coming right back and making full rated power again as soon as the short's removed. Pretty amazing devices. Very, very high mean time to failure on these devices. Typically, we're talking 20,000 years on the rated MTBFs of these devices. I kind of doubt they'll really last for 20,000 years, but we won't be around to find out. So that's the ratings that the manufacturer puts on. Very, very reliable devices. So what this all means is the introduction of new transmitter series about 5 years ago now. We began to introduce this. It's a very mature product now. We introduced the from our customer base to really go at this seriously. We continue to do research. We continue to do fact finding, about what was possible. We continued to talk to customers, and I probably did 20 different SBE and different programs where I would at least bring it up. When we started talking about total cost of ownership, we started talking more and more about it. And I'd say only in the last 3 years or so has it really gotten to be an acceptable topic. Most of the time, the responses I got were, I don't want that stuff leaking all over my transmitter room, and it's dangerous, and the stuff doesn't seal well. And well, little by little, those objections have kind of gone away. First of all, it isn't dangerous. The voltages involved are so little, and the contact of anything with the liquid cooling system, with anything with any voltage on it's kind of non-existent. The technology's gotten so good with these quick connect, quick disconnect, quick seal couplings, liquid couplings. They don't drip a drop. And we've been doing this a long time. So I think just slowly the market evolved and went from almost pushing back on us to almost demanding it in the course of about 3 years. So that's why it took so long. I mean, if you remember the last attempts, our friends at Continental did something that didn't work out real well. Nobody was very happy with that. All the other manufacturers have looked at it. I know our friends up in Nova Scotia have looked at it and just did not see enough of a market. But in the final analysis, we saw enough of a market here to give it a try. And I'll say, along with that, one of the reasons, very honestly, one of the reasons we stuck so firmly to the FAX air-cooled basic architecture and design was to minimize the risk. If this isn't a super successful product, which I think it will be, nothing really lost. We certainly can justify it for the customers who want it. But if it doesn't take off gangbusters, we made a modest and reasonable investment in a good technology. And then the next, if there is a huge demand for this, if there's a groundswell for this, you can believe there'll be more improvements to up the line. So I hope that answers your question, Mark.
He pointed out that we needed this 10 years ago, and that Volkswagen converted the bug to liquid cooling long ago.
Okay. He's absolutely right, and I think we needed this 5-10 years ago, and he's absolutely right. Volkswagen saw the handwriting on the wall and went from air-cooled to liquid-cooled about the same time. So good on you, Mark. I'm glad you're on our side with this one. That's great, buddy.
So there actually are a lot of other questions. There's one from Paul. I really apologize.
Paul Schulens?
Yes.
Hi, Paul.
What is the maximum number of transmitters that can share a common pump and heat exchange? And did you say that the limit is 4?
Well, it's 4 on the 20 kilowatt heat exchanger. It could go up to 8 on the 50 kilowatt heat exchanger. And quite frankly, we that's all theoretical right now. And with a lot of and being very conservative, we've got to look at pressures, we've got to look at temperature drops, and there's a lot of things the mechanical guys want to look at before I go stepping us out on a limb and saying exactly how many, but we're very sure we can run 4 10 kilowatt systems on a single 20 kilowatt system, a single pump, single 20 kilowatt heat exchanger, and we're very comfortable with the 80 kilowatt system being on the 50 kilowatt heat exchanger with a single pump module. And beyond that, we've got to do some more work. So I hope that's answering the question without painting ourselves in too much of a corner right just yet.
All right. Jed Wilkinson asks, why only 20 kilowatts in one rack? Because 80 kilowatts would be much better.
Yeah. Hi, Jed, and thanks for joining us. Yeah, I mean, the reason for the 20 kilowatts in a single rack, believe me, the guys around here know how bad I wanted to do 80 kilowatts in a single rack, and we could have done it. The problem with doing that was it was going to take such a radical change from the air-cooled architecture, which, as I kind of said before, we needed to minimize our risk and minimize the investment on this, and at the same time stay with a very tested and reliable architecture that was proven. We could do the facts. We could do it fairly quickly. We could do it relatively low investment and very high assurance of success with very low risk. And that's why we did this. And when I kind of allude to if there is a huge groundswell for liquid cooling, we certainly have the architecture in mind to bring it up to 80 kilowatts in a single rack. But it's a lot of knobs to turn and a big R&D development effort, a very, very large one. Not that we're afraid of that, but if we've got to see a market for this first.
Dave Hoxing has a nice comment and a nice question. Very impressive presentation. What are your thoughts about using geothermal wells for cooling instead of fan-based outside air heat exchanger? Are you there, Tim?
I did. I hit my button. I hit my mute button. Sorry.
Oh, no problem.
I was just saying, I wish we had the full two-way audio, because if Jed were here, he could pipe in on this. He's actually done it, not with our liquid cooled system, but he has done geothermal. We've had a few talks about it. This lends itself beautifully to a geothermal cooling system, and would so increase the overall efficiency and cost savings. It's perfect for geothermal, and there's been a lot of chatter, a lot of talk about who's going to do the first geothermal system using FLX. I see it just a matter of time before it happens.
All right, and Brian Williston asks, how is the liquid cooling bypassed to keep the PA modules hot swappable?
Oh, great question. Great question, Brian. Okay, so and if I step back, let's see here. Let's see if I can step back through the pictures. We'll go just jump ahead here to the PA modules themselves. And they tell me there's a 40-second delay, so I'll just get to it and we'll leave it there. Okay. The nozzles that you see on the right-hand picture, those are quick seal, quick release disconnects. They're sort of like hose faucets with a pin, and when the pin of the receiving coupler goes into the center of that hose coupler, it pushes a valve in. It's a spring-loaded valve that cuts off on both sides. It cuts off the flow on both sides of the connector. So there's basically a pressure valve on both sides that's spring-loaded. So as soon as you remove the module, it closes that valve and cuts off the flow. Very reliable. We've used these in television really successfully for years, and they just keep getting better. They're very reliable. They don't leak. And a very, very good solution for this. Hope that answers the question.
And I do apologize again for the last name, but I believe it's Chris Cahill, or Coggle. I have floor loading considerations. How much of a weight increase is the liquid cooled over air cooled versions?
Wow. I'd have to actually go look at it, but I gotta tell you, it's not significant at all. It's not even. I don't. We haven't even noticed it. I'm sure it's in our documentation. But the weight increase of liquid cooled over air cooled is inconsequential. It's very, very minor. I'm sure it's a little bit of an increase, but you know we're not talking more than 100 or 200 pounds.
We're coming up to the top of the hour. I think that's actually the questions that we have right now. So if you want to just let people know again what your email address is, and also
Sure.
before you sign off, I just wanted to let everyone know I'm Keith. I'm the marketing communications manager here, and we thank you for being part of this webinar. For those of you who didn't have a chance to catch it from the beginning, or even if you didn't get a chance to catch it at all, or want to see it again, you can actually revisit this exact same page link. That is GatesAir.com/webinar/Flexiva FLX-liquid-cool-FM to see the video, this has entirely been recorded. And you can actually look back and see some of the finer points of what Tim discussed. So again, thank you very much, Tim.
Well, thank you, Keith, and thank you, Teresa and Mark and everybody else who helped put this together. Thanks, Ed Allen. And thank you all for joining us this afternoon. There's my email address. It's tim.anderson@gatesair.com. And you can certainly drop me a line anytime if you think of other questions. So thanks, everybody, for joining us this afternoon. I'll look forward to seeing you all. I'll be in Tampa tomorrow for the SBE Chapter 39 meeting and probably be talking about much the same things. So you all have a good afternoon. We'll talk to you later. Bye-bye.